Hello, college algebra student. This video is for chapter 3.1 to 3.2 online homework. So follow along to get help. Especially, I think the last question for graphing is quite tricky. But just follow along if you need help. Otherwise, you can just skip to whatever question that you need help on. Question 1 is for evaluating a function at certain place. They give the function f of x is x squared plus 8. And we have to do f of 5, f of a, all those. So let's go to our notes to do. Okay, go back to the top first. So f of 5 is just a substitute, right? You just plug in. So basically you will say, okay, whenever I see 5x in the formula, I substitute 5. 5 squared plus x is 25 plus x is equal to 33. What is f of a? Whenever I see x, I put a. So just a squared plus 8, we can add a squared and x, so that would be the simplest form. A plus 1 square, a plus f of a plus 1, that means whenever I see x, I plug in a plus 1. So that is x, something square plus 8. So, but I want to FOIL the a plus 1 out first. A plus 1 times a plus 1 is first and first. You go to a square, first and last, plus a, middle, inside, plus a and plus 1. So turns out to be a square plus 2a plus 1. And so I would write a square plus 2a plus 1 plus 8. Oh, plus 1 and then plus 8. So that would be a square plus 2a plus 9. Right? Last one is f of a and then f of 5. So now notice we have to plug in a first and then we have to plug in 5 and add them. So basically I have f of 5. I have f of a. F of a is a squared plus 8. We have it already here. And then f of 5 is 33. So don't plug in a and 5 to it together, but plug in separately. So that would be a squared plus 41. Go back to submit the answer. Oh. I think there's something wrong here. Then I can switch back. Okay. How come this one is not working? Oh gosh. What's going on? All right, okay, go back. What was the answer? What was the answer? 33. This is 33. This is a square. Oh gosh, a square plus 8. A square plus 8. Next one was a square plus 2a plus 9, I think. And then this is a square plus 41. Oh, sorry. Plus 41. So, more function notation. If f of x is 5ax minus 2, simplify. What is f of a? Oh, this one I can just do it because there's nothing to do. You just replace your x by a. F of a plus h, oh, I need some work, right? So I'm going to scroll down here. There's something wrong with this. Okay, so now I can scroll down. f of a, we already did, f of a plus h. I have to simplify a plus h, right? Five of a plus h minus 2. So that would be 5a plus 5h minus 2. And that would be this one. 5a plus 5h, but minus 2. And what about f of a plus h minus f of a over h? So I have f of a plus h, which is 5a plus 5h minus 2. But minus f of a is 5a minus 2, right? So, and I distribute and then over h. Now I'm going to distribute. Will be 5a plus 5h minus 2 minus 5a plus 2. So this is distribute. Minus 5a plus 2. Minus 2 plus 2 get rid 5a minus 5a, 5a. So only 5h over h. H and h cancel is equal to 5. So this is 5. This is 5a plus 5h minus 2. Okay, so this is the more difficult one, 3x squared plus 3. And then we have to do f of a plus h. So that means 3, the input is x, a plus h, that. So we would need to do 3, FOIL the a plus h. If you FOIL it in class, you know a plus h times a plus h is a squared plus ah plus ha plus h squared. But HA and HAH is actually the same thing. So we say A squared plus 2AH plus H squared. And it's always like that. So we would be A squared plus 2AH plus H squared. And then I plus 3. And then what you do is you just distribute plus 6AH plus 3H squared plus 3. And that is f of a plus h. It's really long. So 3a squared plus 6ah plus 3h squared plus 3. The other one is f of a plus h minus f of a. So I have f of a plus h right here already. My f of a is 3a squared plus 3. So it would be 3a squared plus 6ah, you'd have to keep track, plus 3h squared plus 3 minus, open parenthesis, 3a squared plus 3, right? And then all over h. Oh no, this is just that, not all over h. Yeah, the next one is all over h. So yes, you erase this. So when I subtract them, can I simplify something? Yes, I have to distribute this. So this means minus 3x squared minus 3. So the plus 3 and minus 3 cancel, the a and a cancel. So end up having 6ah plus 3h squared. Our 3 cancel. So only 6ah plus 3h squared. 6ah plus 3h squared. Syntax error. Oh, 6ah plus 3h squared. Last one is to get that divided by h. So I'm going to do it in the work. So I know this divided by h means, let's do it in here. 6ah plus 3h squared, and I want it over h. I can't just cancel one of them. I have to factor the h out. I could factor more, but I just want to factor h out because that's what I want to cancel. 6a plus 3h, right? And then I over h. Now then I can cancel. It's 6a plus 3h. Quite tricky when you need to do FOIL. Okay, so now this is reading f of 4 from a table. X is input 4, output is 48. So you read off the table what x is, the corresponding y value. So solve f of x equal to 2. So that means x, I have y, I want x. Look at when y is 2, x is 6. Right? When y is 2, x is 6. 5, another one, f of x, f of 2. So I will look at when x is 2. Okay, go back in the notes. Oh. Somehow this stuck sometimes. Yeah. So we did this already. So I want to do f of 2. So x is equal to 2. This is x, right? This is x-axis 2. And I will look up and down. So I will see this point. This one is 2, 6. So my f of 2 is 6. So that is equal to 6. And what about f of x equal to 2? That means y is equal to 2 and what is x? So we got a y and we look sideways. This point is 3, 2. So your x must be 3, right? So x must be 3 to get 2 because it's 3, 2. Oh, this is not 6. F of 2, f of 2, f of 2, is it 6? 1, 2. Oh, this is a 4. Okay. Okay, this is x and y. What is the domain? The domain, if I have table, then I just list all the x out with no repeat. 17 and then -9. Range means all the y, also no repeat. If there's the same number, you don't need to do it 2 times. But we only have individual number. Okay, so we just submit, see if it works. It works. Is this a function? I think so. I only have 1x go to 1y. Yes. Okay, so this is a graph. We wanted to find a domain. Domain is all the x. So x is from -4 to 1. So horizontally, this is the x. But -4. Oh, okay. We would say -4 less than equal to x, less than equal to less than equal to 1. But this is a less than equal to that. Then for the range is up and down, how tall x and y is, how tall y is. The lowest y is -4, the highest is 5, right? So we say -4 again, because this is the -4. Y equal also. Was the highest? It's actually 5. It's not this one, it's 5. It's the highest y recorded. For the domain, we know that we want to exclude x is equal to 3, right? Because when someone writes something over x minus 3, that's really strange. Yeah, okay. We did this, we did this. So x cannot be 3, so we can figure out when is x equal to 3. It cannot be. So that means this is 3 is the only place that's open. My number line are like this. So it will be -infinity to 3, but not including 3. And then from 3 to infinity. So be in the interval cannot be 3, so be like that. Negative infinity, comma 3, but not including 3, union another 3 to infinity. So it's just all number except 3. This is the long way to write it. Question 9, what is the domain of this function? So unlike a denominator for domain of a square root, you don't want a negative number. So long as you have x plus 2 is greater than or equal to 0 is good, right? So when you see this, you solve an inequality of x minus 2 greater than or equal to 0 plus 2, x is greater than or equal to 2. Again, greater than or equal to 2 in interval notation. I have to draw the number line. Draw the number line. Greater than 2. So from here, does it include? Include 2. So it will be 2 comma infinity. Interval notation 2 comma infinity. Then submit. For each of the following expression, list the domain restriction where it would be defined. So x cannot be what? Oh, I have to factor it first, right? Because I can't just look at, and because this is not SEC of x minus 4, we have to look at the denominator. So this would factor as 56 multiply, add to be negative 15. But 8 and 7, negative, negative, I think. So be x minus 8, x minus 7 for the factor. But that means I want to exclude what? I want to exclude 7 and 8. Right. Cannot equal to 7 comma 8. What about the second one? Again, I factor one more time. This one. We know it is x and x. So we negative 24 multiply. Add to be 5. What two number when they multiply? 3, 8, right? But negative 3, x minus 3, x plus 8. So when it is a 0, you cannot be 5 or negative 8. Find the domain of 2x squared plus 5x minus 4. Well, this is not a denominator, it's not a square root, so it's very easy. It's just all real number from negative infinity to comma infinity. Just all real number. If it is just a formula, you can plug in anything you want. So this is a piecewise function. 7 over is for x less than 0. If x is greater than 0, is square root of 3x squared plus 1. So negative 2 is a less than, the x value is negative less than 0. So I always put 7 as the answer. Above 0, I would use this formula. So that would be 1 because 3 times 0 is 0 plus 1. Square root 1 is 1. What about 2? So 3 times 2 squared is 3 times 4, 12. 12 is square root 13. So you just enter the exact value. Okay. 12 given, so we have to graph 3 graph. One is when x is less than negative 1, it's always 1. So because it go from one side to the end, so you pick this line segment. And then it start from x less than negative 1 and all the way, and it's the y value, the x value is just like this. Second is x is between negative 1 and 1. So let's calculate what happened. Yeah, let's calculate. when x is between -1 and 1, we need to calculate the boundary. It means when x is -1, usually we don't plug it in. We don't plug it in because when it is actually equal to -1, you should use. Am I doing this? Yeah. Am I doing this question correctly? Yeah. Okay. So you will say, well, x equal to -1, you should use this formula, but when it's just close to -1, we can kind of find the boundary. So plug it in. It will be -2 times -1 minus 1. 2 minus 1 is 1. So there should be a open circle at -1, 1. So -1, 1, so you open circle it. And then when x is greater than 1, oh, okay, we have to do another boundary which is equal to 1. So that is equal to -2 times 1 minus 1. That is -3. So there's a point of 1, -3. Yeah. One -3. So when it is 1, it's down at -3, and that's the 2 point that we need to connect. Right? Then for the other two, they should be solid because x is less than -1. So it's equal to 1 solid. Oh, it's actually the same place. And then when it's greater than 1, at 1, it was -2. This is solid here. And then this is open all the way -2. Or the y value is -2. So we will have a point here, thing like this. 1, -2, I think. Is it 1, -3? Oh, 1, -3. Okay, clear. Oh gosh, we have to clear all. Okay, so this is -1. Yeah. And then we have a line segment which is from here draw to 1, -3. And then the end is from greater than 1. So you will say this again, greater than 1 is -2. Yes. Should we get a open circle and solid circle and all those? I think that one is solid. This one is open. Yeah, this is solid. Oh, okay. I think maybe I should dot this one. -2, 1. What is -1 is 2 minus 1 is 0, 1, 2, 1. I think this is fine. Okay, so let's clear again. Let's try -1 when it is here. But, oh, maybe I'll just put a dot here. Maybe that's the problem. Oh, clear all. How come it's so hard? -1, go all the way. And then put the dot. Well, they actually are connected. 1, click the line segment 1 and then down -3. But this one is at 1 is a dark circle. And then at that one, oh no, it's this one. It's -2, right? So -2 the way, and then we put the solid. Yes, I think there's something wrong earlier. Okay, so that's all for 3.1, 3.2.